Imagine standing on Mercury, the sun blazing above you with no atmosphere to protect your skin. Temperatures rise high enough to melt lead, but here's the twist. Mercury still doesn't hold the record for the hottest planet. Another world is cooking even more fiercely. Which one? And how is that even possible when Mercury is the closest rock to the sun? In this video, we'll explore the science that flips our expectations upside down, and what it says about the power of atmospheres, distance, and energy traps in shaping planetary environments across the solar system. When most people think about the hottest planet in the solar system, they point to Mercury without a second thought. It feels like the obvious answer, right? After all, it's the closest planet to the sun. But here's the thing. Being close doesn't automatically make you the hottest. Mercury actually doesn't hold that title. And the reason comes down to something most of us take for granted every single day: an atmosphere, or in Mercury's case, the lack of one. Now, Mercury is by no means a cool or comfortable place. During the daytime, if you were standing on its surface, the sun would burn down brighter than it ever could on Earth. With no protective layers to filter that energy, Mercury's ground bakes to extreme levels, reaching around 430 degrees Celsius, or about 800 degrees Fahrenheit. That's hot enough to melt metal. Imagine standing there with the rocky surface underneath you, glowing with heat, no air, no clouds, and no shield between you and the sun. It's intense, maybe even unbearable, at least during the hours when sunlight is there. But here's the twist. As soon as Mercury rotates and night comes around, everything changes. Without the blanket of an atmosphere to hold on to that daytime heat, all of it radiates back into space almost immediately. Temperatures crash to about minus 180 degrees Celsius, or negative 290 degrees Fahrenheit. That's like going from the inside of an oven straight into a deep freezer in the span of a single planetary night. If you were standing there on the shadowed side, your surroundings would be silent and frozen, a complete opposite of the burning landscape you just left behind. No planet brings night and day to such extremes. That wild swing in temperature is the key to understanding why Mercury isn't actually the solar system's frying pan. Atmospheres trap heat. They spread it around. They make temperatures more stable. That's exactly what happens here on Earth. Our atmosphere takes the sun's warmth and redistributes it, preventing our nights from dropping hundreds of degrees. Even the balance we live in is fragile, and we see how greenhouse gases and clouds add or remove insulation. Without them, Earth would be colder, harsher, and much less hospitable. And this is where most people stumble, because it seems natural to think that the closer a planet is to the sun, the hotter it will always be. But heat isn't only about distance. It's about whether you can trap and store energy. Mercury, despite how close it orbits to the sun, has nothing holding that warmth in after sunset. So yes, parts of it absolutely scorch when sunlight hits, but on average, it comes out cooler than you might expect. Let's put numbers to it. Mercury's average surface temperature sits around 167 degrees Celsius, about 333 degrees Fahrenheit. That is hot, no question, but not unbeatable. Compare that to Venus, which is farther away from the sun, but much more consistent. Venus holds an average surface temperature around 464 degrees Celsius and 867 degrees Fahrenheit. And unlike Mercury's extremes, it barely changes between night and day. That's the proof that atmospheres matter even more than distance. So Mercury's downfall is simple. With almost no air above it, it can't trap warmth like its planetary neighbors. That thin exosphere it does have isn't enough to hold even a fraction of the daytime energy. Once you realize that, it makes sense why Mercury falls short of being the true oven of the solar system. And that raises the question, if not Mercury, then which planet earns the title of the ultimate furnace, where heat doesn't fade but lingers endlessly? It might come as a surprise, but the hottest planet in our solar system isn't the one closest to the sun. Venus sits further out than Mercury, yet it leaves Mercury far behind when it comes to searing temperatures. The reason? Venus has something that Mercury does not: a massive, dense atmosphere that acts like a thick blanket, holding every bit of heat in and refusing to let it go. That atmosphere is almost entirely carbon dioxide, with only traces of other gases. Imagine it as a planet-sized pressure cooker, trapping the energy that pours in from the sun, Unlike Earth's atmosphere, which helps regulate and circulate heat more evenly, Venus's blanket is far too heavy and efficient. It doesn't just keep the planet warm, it locks it into a constant state of overheating, and scientists call this a runaway greenhouse effect. Sunlight filters through the clouds, but once it's absorbed by the surface, the energy can't escape. It gets bounced back down over and over until the entire world is smothered in relentless heat. Adding to this already extreme setup, Venus is covered in thick clouds filled with droplets of sulfuric acid. These don't just look ominous, they help scatter light across the atmosphere, but at the same time, they support the heat-trapping layer below. On top of that, the sheer air pressure on the surface is staggering, over 90 times greater than what we feel on Earth. Standing there would feel like sinking nearly a kilometer underwater in our oceans, except instead of water pressing down on you, it's a crushing wall of toxic gases. When you look at the numbers, the scale of Venus's heat trap becomes clear. Average surface temperatures are about 464 degrees Celsius or 867 degrees Fahrenheit, and they barely change whether it's daytime or nighttime, equator or poles. That means while Mercury swings between extremes depending on the light, Venus stays consistent. Always blistering hot, everywhere, all the time. It's like being stuck in an oven that never cools off. And the planet maintains this balance with stunning efficiency. A good way to picture what's happening is to think about a car parked in the middle of summer. Sunlight streams in through the windows, warms the interior, and then that heat gets trapped. After only a few minutes, the inside of the car is far hotter than the outside air. On Earth, you can crack the windows and let some airflow balance the system. On Venus, there are no windows to let the heat escape. Once energy enters, it is completely sealed inside. Multiply that car effect by an entire planet, with an atmosphere hundreds of times thicker than what we breathe, and you see why Venus stays hotter than Mercury despite its distance. What's even more startling is the toll this environment takes on spacecraft. The Venera missions sent by the Soviet Union in the 1970s and 80s landed successfully, but they only survived between 20 minutes and about 2 hours before their electronics melted or failed under the punishing heat and pressure. Later missions, like NASA's Magellan orbiter, could only map from high above, because landing again meant instant destruction. Just the act of touching the surface is literally too much for most technology to handle, which shows how intense the conditions really are. And that brings us back to the bigger picture. Venus is the undisputed furnace of the solar system, not because it sits closest to the sun, but because its atmosphere is a near-perfect trap for heat. That same principle, how gases and pressure can shape worlds, has massive implications. It not only changes how we see exotic planets circling other stars, but also forces us to think about the balance here on Earth, and how fragile even small changes in our own atmosphere can be. So, the real lesson here is that the hottest planet isn't always the one closest to the sun. What really matters is how effectively a planet traps and holds onto heat. That's why Venus, with its dense carbon dioxide atmosphere, outpaces Mercury so completely. Thinking about Venus forces us to reflect on our own planet. Earth's atmosphere also regulates heat, but even small changes can have huge effects over time. If one planet can overheat this way, we have to take our own balance seriously. And then imagine, out among distant exoplanets, worlds even stranger, hotter, and more extreme.